I'm going to talk about another method called the washer method. So essentially, if you, instead of having a boundary at either the x or the y axis and zooming around that, where the radius is going to be the same, we've got some voids here. So if we're looking at this, this over here, we're trying to take this piece and rotate it around the x-axis. Well, if you know, what you can do is you can use the disk method, make the disk from the upper function, that f of x, and then make a disk from the lower function, which in this case would be, your g of x is equal to 1, and you'll have a disk within a disk, essentially. So what's going to happen is you're going to have the outer disk, and then there's going to be a hole in the center. It's going to look like a washer or an annulus. And this is our function, or our formula to do so. So you have to have the continuous non-negative functions, and you have to have one greater than or equal to the other over the interval. So if it starts to do weird stuff, you got to move it around. So the top function minus the bottom function, again, each of them squared, is going to be the radius. So f of x will be our outer radius, and g of x will be our inner radius, which will be removed. Now this problem 81 asks us to use the disk method. Essentially, it wants us to use the disk method for part of it. We have to break this up. I've already looked at the problem. We're going to have to break it up into two pieces, and it wants us to use the disk method. Again, you can, but really what we're using is called the washer method for part of it. So let's draw our graph. So x plus y equals 9. So let's go up by, I guess, 9. 1. So there's 9. There's 9 up there. So you've got one function here. That goes just like that. And we're not going to go any further because we have this y equals 0 and x equals 0. So we're going to contain our answer to the first quadrant. This next one, or this other one here, this x squared minus y squared equals 9, is a hyperbola with foci of root 9, which is 3. So it's going to look, something like this, and then negative 3 as well. So I'll draw it, but we're not going to really need it. It looks something like this. That's what your hyperbola is going to look like. So the area of interest is going to be within this. That is what is where the four bounds, that's what they contain. And we're going to rotate this around the x-axis. Well, from 0 to 3, we simply need this this function here. Let's redo it. This is y is equal to 9 minus x. That's going to be our f of x, right? For the points 3 to whatever, we need to find out where they intersect over there, and let's do a little algebra to see that. All right, so let's look at this. We have this function here, which gives us y squared is equal to x squared minus 9. And here we know what x is, so we can replace it. Right? Yeah. So here we have x is equal to 9 minus y. So we want to know where these are going to be equal, so let's plug these in. So y squared is equal to 9 minus y squared minus 9, which means This is 81 minus 18y plus y squared when we FOIL that bit, and then we have the negative 9 left over. The y squares are going to cancel. So I'm left with 0 equaling, what do we have, 72 minus 18y. So 18y equals 72, which means y is equal to, what is it, 4. So if y equals 4, that means we have x plus 4 equaling 9 from our f of x, which means x equals 5. So this point here is the point 4, 5. I don't know that we need the 5, but we certainly need the, excuse me, not 4, 5, 5, 4. So we very much need the 5. So that's 5, 4. So 1, 2, 3, 4, 5. So our next interval is going to go from 3 to 5. But you'll notice that there's a void there, so we're going to use that washer method or the disk method twice, essentially, to find that second part. All right, so room. Let's try it right here. We'll see what we can do. So our volume here for the first part goes from 0 to 3. And that's going to be, there's a pi out front, and we have that 9 minus x quantity squared dx. We're going to add that to pi, and then we have the two different ones. We're going to go from 3 to 5, and we're going to take the 9 minus x squared. Let's see if I can move this around a little bit. There we go. 9 minus x squared, and then minus our g of x squared, which is this part here, which we've determined to be I guess if y squared is x squared minus y. Then y equals, excuse me, that's a 9, not a y. Y equals root x squared minus 9, so we found before. All right, so this is going to be root x squared minus 9 quantity squared. That'll be the inner part of that disk. So that's what we have here. So our volume, we can FOIL this out. And what do we have? 81 minus 18x plus x squared. And maybe this would just be easier to do as a complete disk method. Just do the top and subtract that lower part. So take this first one from 0 to 5 and the second one as 3 to 5. But I'm down the rabbit hole, so I'm going to do it this way. All right, so this is 3 to 5. And this is that same 81 minus 18x plus x squared minus the quantity. Since we're squaring the square root, it's just x squared minus 9. All right, this part here is not bad to evaluate, and we'll just do that with the next group as well, and make that other bit work. Let's see, this is just 81x. This would be negative 18 over 2 x squared, so negative 9 x squared. And this last bit is plus x cubed over 3. This is all evaluated from 0 to 3. We're also going to have this whole thing evaluated from 3 to 5. So I'm going to actually probably do what I should have done in the first place. Move this over and change this 3 to a 5. And then we're going to be subtracting, let's see, let's change this back to orange. We will be subtracting this part here, and there's a pi there, so pi, the integral of x squared is going to be x cubed over 3, and the integral of 9 is just, I guess negative 9 is just negative 9x. That's evaluated from 3 to 5. All right, let's see. Plugging in 0 kills this whole left side, so we're just going to plug in the 5. And we need both a 5 and a 3 here. So the 5 first. And then minus the 3. So 3 cubed, and 9 times 3. Okay. This is a hot mess. All right, so we have 81 times 5. What do we get? A 5, and then 40. 5 squared is 25. 9 times 25. We're looking at 225. And 5 cubed is 125. Okay. Minus 45. And then here we have, this is minus 3 cubed, so that's 27. And this will be a plus 27. Okay, anything I can cancel? Well, I have a 125 over 3, and because this is negative, a negative 125 over 3, those go away. 27 over 3 is just 9. So let's take a look here. So this is equal to pi, what do we have here? 405. So 180 on this side. And again, here we have, looks like we're going to be minusing, so we have this is 9, that's 9. So this whole thing looks like 9, right? No, that is not 9. So let's do this. We have negative 45 minus 9 plus 27. So that's negative 54, and 27 gives us negative 27. So this is minus and another minus, so minus pi times minus 27. So that's 180 plus 27, which is 207 with a pi. All right, I apologize for the long-naturedness of that question, but it looks like we came to the right answer, and if you see something wrong, please let me know.